Hello and welcome to another edition of the Lighthouse Video Series. I'm Stephen Madill, the Executive Vice President of Sales and Marketing for Nichols Portland, Inc. We're coming to you from our Ridgway facility in Ridgway, Pennsylvania, where we do the Sintered technology. With me today, I have Seth Weible, a lead engineer in our facility here, and Howie, our VP of Advanced Engineering. Gentlemen, thank you for joining me. So this topic today is a pretty simple one. It's the basic fundamentals or basic topic of the Sintered technology or PM technology. Obviously, there's a lot we could talk about, but at a high level, just talk about maybe what the process is. And Jeff, maybe you can start that with where it starts.
Yeah, so powder metallurgy or sintered metal technology, if you will, it's a metal forming technology. It's a near net shape or net shape manufacturing process. What makes it unique from other metal forming processes is it starts with the raw material is actually in powder form. It's atomized metal, which is blended to whatever alloy you need prior to the actual manufacturing process that we do. It's very high utilization in that there's not really a lot of net waste from start to finish. Typically, you're well above 90% material utilization from start to finish. The basic process is you start with the raw material in powder form, you compact it, and you sinter it. So with that, I'll hand it over to Seth to talk about compaction.
So the compaction process really starts off in the artistic stage of the tool design and tool build. And that's where you can get different levels, different splines, different OD gear profiles that are very expensive to get inside of other metal forming technologies.
Right.
Once those are complete, those get put inside of a powder metal press where it has a little bit of a mezzanine up on top of the press where the powder that Jeff alluded to before gets loaded, gravity fed down into a feeder shoe. In the actions of the press will push the feeder shoe over top of the tools, fill it with the powder, retract back, and that's when the press will cycle and you get a green part. So during the molding process, the powder gets or experiences a pressure of about 35 to 50 TSI, which, putting into perspective, if you have a little bit of a 1 square inch area and then balance 20 to 25 F-150s on that 1 inch area.
Yeah.
Yep, that's it's
a little pressure.
Just a little bit.
Yeah.
But yeah, that's the pressure that the powder is seeing inside of the molding process.
Yeah. And at that point, it's a green part, what we'd call a green part, which means it's not sintered yet. And maybe, Jeff, you can walk us through how we take it from a green part to a metal part.
Yeah, so the green part is all of those little metal particles that start out as the raw material. They're all mechanically interlocked together, and there's a little bit of lubricant in there that also kind of binds it together. So you can handle the part at that point, but it's very fragile. If you were to drop it on the ground, it would break like a stale cookie. We then put the mechanical properties into that material through the sintering process. So the part is conveyed from the press into the furnace. The first step of the furnace is to burn out any of the lubricants from the compaction process. And then it enters into a high heat zone, which, for the average steel alloy is around 2100 degrees Fahrenheit or 1120 centigrade Celsius. And it's kept in that high heat zone for about a half an hour. That's how long it takes to bake in a very specific atmosphere to prevent any oxides from forming on the part. After about a half an hour of high temperature, what we call sintering, the part comes out of the high heat zone, starts to cool off, and then it can be handled coming out the back end of the furnace. From start to finish, it's about a 3-hour cycle, but because it's constantly running, that furnace is putting out hundreds of, not thousands of parts an hour.
And then there's many different types of furnaces out there. The two predominant ones that we use are belt and pusher. Maybe you can kind of allude to what the difference is between the two of those.
Yeah, so the lower end of that temperature scale, around 2100 Fahrenheit, the belt just constantly flows through at a few inches a minute through the furnace. The furnaces are about 40, 50 feet long. And the belt can survive at that temperature. For the higher temperatures, up around 2500, 2600 Fahrenheit, the belt would stretch out and in some cases kind of just deteriorate very quickly.
Right.
So we use little high temperature resistant boats that we put the parts on, and then the furnace just pushes in one boat every minute or a couple of minutes, and it takes just as long to sinter them, but it's just at a much higher temperature. And one thing I didn't mention earlier is we never get to the melting temperature of the base metal. There may be some constituents in there like copper, which goes into liquid phase.
Right.
We're always just below the melting temperature of the metal to maintain the dimensional stability of the part through the furnace. And just with the amount of energy, the heat energy going into the individual particles, that's how they bond together. Yeah. So it's not like welding or melting, it's fusing at the atomic level. Right. Those particles come out the other end of the furnace as a solid part. Like I mentioned earlier, if you drop that on the ground, it'll dent the concrete or break the concrete. It's not going to break the part.
Right. Yeah. Yeah, it's an interesting technology. It's a green technology. You mentioned earlier that, we don't have a lot of waste. A lot of our product is net shape. Right. The other part of it is our raw material comes from scrap steel for the most part that they've melted. So it's a very green technology, very good for sustaining our environmental targets and such. So it's a very interesting technology.
Yeah, and the ideal PM part comes out the furnace and it's ready to go into whatever the final assembly is that it's going into.
Right.
Anymore, just because of tighter tolerances required in our industry, there can be secondary operations further down where we remove a little bit of material just to get the tolerance.
Right. And we're going to have a separate video on those possible operations. So, gentlemen, thank you for the insight. It was very helpful. If you would like to learn more, as we've touched at a top level here of the basics of the technology, we would be happy to come to your facility and do what we call, a lot of people call them a 101, a lunch and learn, tech day, whatever you'd like to do. We love teaching our technology to those who can benefit from it. You can contact us by going to our NicholsportlandInc.com website, and through the website, contact us and we'll reach back out to you once you do that. So we thank you for your time.